modern computer systems, optical components become smaller and smaller, and this is why they can become integrated into computer systems, and the number is starting to increase. And while we're doing this, we see that the footprint and the energy consumption of these components becomes more and more an issue. So we are looking into novel ways how to reduce the energy consumption while at the same time also reducing the footprint. In normal computer systems, for example, like for a transistor, when you shrink the components consume less power and become faster. For most optical components, this is not the case. So we are looking into ways, for example, to exploit quantum effects in order to compensate for this loss in performance for these optical components when shrinking. Albert Einstein and a young scientist from India, Bose, and they together predicted that at the very lowest temperature that one can achieve, all the particles will condense into the same quantum state, so to say, and this is the so-called Bose-Einstein condensation. You can think of it as all the particles will march in lockstep, in contrast to like billiard balls, which are they more behave like at normal room temperature. Bose-Einstein condensation is a very old phenomenon, very long predicted and only realized very recently, and now more or less most recently it has been succeeded to realize these things at room temperature, and this is where it becomes interesting to use it for real devices like for photonic devices. And these Bose-Einstein condensates, when realized in a solid state like in a crystal or in a semiconductor, they can emit very coherent light, which is really like the light from a laser. And in principle, this light is much more generated in a much more energy efficient way than in a laser. So the hope is to create very energy efficient lasers from this Bose-Einstein condensate.